And it involves looking at the change in the function that you're interested in differentiating. So I should look at how much the product uv changes when x changes a little bit. Well, so how do we compute the change? Well, I write down the value of the function at some new value of x, x plus delta x. Well, I better write down the whole new value of the function, and the function is u times v. So the whole new value looks like this. It's u of x plus delta x times v of x plus delta x. That's the new value. But what's the change in the product? Well, I'd better subtract off what the old value was, which is u of x times v of x. OK. Now, according to the rule we're trying to prove, I have to get u prime involved. So I want to involve the change in u alone by itself. Let's just try that. I see part of the formula for the change in u right there. Let's see if we can get the rest of it in place. So the change in x is u of x plus delta of x minus u of x, right? That's the change in x. It occurs, this part of it occurs up here multiplied by v of x plus delta x. So let's put that in too. Now this equality sign isn't very good right now. I've got this product here so far, but I've introduced something I don't like. I've introduced u times v of x plus delta x, right? Minus that. So the next thing I'm going to do is correct that little defect by adding in u of x times v of x plus delta x. OK, now I've canceled off what was wrong with this line, but I'm still not quite there because I haven't put this in yet. So I'd better subtract off u of x, u times v, and then I'll be home. But I'm going to do that in a clever way because I notice that I already have a u here. So I'm going to take this factor of u and make it the same as this factor. And so I get u of x times this minus u of x times that. That's the same thing as u times the difference. So that was a little bit strange, but when you stand back and look at it, you can see multiplied out, the middle terms cancel, and you get the right answer. Well, I like that because it's involved the change in u and the change in v. So this is equal to delta u times v of x plus delta x minus u of x times the change in v. Well, I'm almost there. The next step in computing the derivative, take the difference quotient, divide this by delta x. So delta of uv divided by delta x is, well, I'll say delta u divided by delta x times v of x plus delta x. Have I made a mistake here? This plus magically became a minus on the way down here, so I better fix that. Plus u times delta v over delta x. This u is this u over here. So I've just divided this formula by delta x, and now I can take the limit as x goes to 0. So this, as delta x goes to 0, this becomes the definition of the derivative. And on this side, I get du dx times, now, what happens to this quantity when delta x goes to 0? So I'm getting closer and closer, so this quantity is getting closer and closer to x. So what happens to the value of v? It becomes equal to x of v. That uses continuity of v. So v of x plus delta x goes to v of x by continuity. So this gives me times v, and then I have u times, and delta v delta x gives me dv dx. And that's the formula. That's the formula as I wrote it down at the beginning over here. The derivative of a product is given by this sum.